So, Professor Loeb, your recent paper suggests that this object might actually be alien technology rather than just another comet.
A week after 3I Atlas swept closest to the Sun, astronomers expected ordinary comet behavior. Instead, they witnessed a sudden vanishing act. New data shows the interstellar visitor's brightness plunged and its emission split, hinting at a catastrophic breakup without any visible debris. If this is not a routine solar pass, what is really tearing an alien object apart, and what will the evidence reveal next? On October 30th, 2025, 3I Atlas reached its closest point to the Sun, a moment astronomers had circled on their calendars for months. The object's hyperbolic path, never to return, meant that every second of visibility mattered. As the clock ticked past perihelion, research teams worldwide scrambled to coordinate observations. Within hours, a global alert went out across astronomer networks, from Telegram comet channels to minor planet center bulletins. The urgency was unmistakable. 3I Atlas was now receding from the inner solar system, and the window for high-quality data was closing fast. Unlike periodic comets, which offer repeat chances for study, interstellar visitors like this one are one-shot phenomena. The scheduling scramble was immediate. Major telescopes, from Hubble to the Very Large Telescope, faced overlapping requests. Amateurs and professionals raced to secure any available observing time, knowing that the next few nights could define the scientific legacy of 3I Atlas. The object's trajectory, confirmed to be hyperbolic, placed it beyond Mars orbit just days after perihelion. Data began pouring in at a volume rarely seen for a comet, as teams tried to capture every possible photometric, spectroscopic, and imaging signature before the object faded into deep space. The sense of urgency was not just about capturing a rare event, it was about seizing a fleeting chance to study material from beyond our solar system, before it was gone forever. Frank Niebling, working from his remote observatory in Spain, captured a sequence of high-contrast images that forced astronomers to reconsider what they thought they knew about 3I Atlas. By stacking dozens of long-exposure frames and digitally enhancing the contrast, Niebling isolated features invisible to the naked eye. Instead of a single compact nucleus, the processed images revealed several distinct sources of emission, bright knots spaced along the coma, each shining with its own intensity. This was not a textbook cometary core. The photometric curve told a similar story of upheaval. Within hours of perihelion, optical brightness plunged far faster than any standard comet model could account for. Typically, a comet's light fades over days or weeks as it recedes from the Sun and its surface cools. Here the drop was compressed into a single night, an abrupt descent matched by a simultaneous fall in gas production rates. The data suggested that large patches of the object's surface had been stripped away or vaporized, exposing fresh volatile-rich layers that rapidly boiled off under solar heat. Niebling's imaging pipeline, scrutinized by peers and cross-checked against other observatories, confirmed the authenticity of these features. The multiple emission centers and the steep hour-scale decline in brightness pointed to a rapid physical transformation, one that left established comet models scrambling for answers. No debris cloud stretches behind 3I Atlas. Instead, the region around the object remains startlingly clear, with nothing resembling the dense dust fans or fragment chains that usually trail a comet after a major disruption. This absence stands in sharp contrast to the drama implied by the rapid brightness drop and multiple emission centers. Yet the comet's tails tell a different story, one that has heliophysicists reaching for new models. The ion tail, made of charged particles stripped from the nucleus, bends nearly 90 degrees away from the usual Sun-comet line. This sharp kink matches the direction of the local solar magnetic field, which shifted abruptly as a high-speed solar wind swept past during perihelion. At the same time, a long narrow anti-tail points straight toward the Sun, formed by larger neutral dust grains, lagging behind on the orbital path. Both tails remain crisp and well-defined, with no sign of the broad chaotic plume expected after a breakup. One heliophysicist observed that the Sun's magnetic field lines are painting the comet's secrets across the sky, while the usual debris is missing. The paradox is clear, something dramatic has happened, but the evidence is written in the geometry of the tails, not in a cloud of fragments. Avil's calculations have put the spotlight on a stark energy imbalance. He argues that the amount of sunlight striking 3I Atlas during perihelion should have vaporized any typical comet nucleus outright. The only way to reconcile the measured brightness and gas output is to assume either a much larger emitting surface area, implying rapid fragmentation, or an unusual structure that exposes fresh layers without total dispersal. Loeb's model, published just days after the Hubble alert, lays out the numbers. The required mass loss rate surpasses the survival threshold for ordinary porous ice. Yet not all experts agree that the comet is gone. Some point to the possibility of a layered shell, a thin, fragile crust that flakes off under solar heating, briefly increasing the active area while leaving a smaller, still active core behind. This could mimic the explosive energy release predicted by Loeb without a full-scale breakup. Meanwhile, spectroscopists have confirmed a striking chemical twist. The outgassed material is dominated by carbon dioxide, not water, a pattern almost unheard of in solar system comets. This volatile mix may help explain both the resilience and the rapid silent mass loss. The next phase is already scheduled. Hubble will revisit 3I Atlas in a matter of days, joined by ground-based spectrographs tracking the carbon dioxide signature. If the brightness curve flattens, the layered shell scenario gains ground. If it drops further, Loeb's disintegration verdict looms. The coming weeks will deliver the answer. With every telescope proposal now racing the clock, observers are watching whether brightness stabilizes, which would suggest a surviving but damaged nucleus, or whether fading continues, which would confirm ongoing fragmentation and expose interstellar material in unprecedented detail. Either outcome would reshape our understanding of what interstellar objects are made of and whether natural processes alone can explain what we are seeing. Right now, 3I Atlas challenges every model of comet physics. If its secrets hold, we may soon glimpse interstellar chemistry, proof that what survives the sun could reshape how we see the cosmos.
It's not a fake, guys. 3I Atlas alien spaceship. Be part of the solution, not part of the problem. Remember the drone sightings back in December? Just the advanced team. 5 to 7 jets from all around. The outer shell of this 33 billion comet is in its depressurization phase before whatever is inside the protective layer comes out. This is exactly how, in theory, humans would manipulate comets for interstellar travel. Or it can back thrusters or both.